this video, we will be discussing about find score of an array after marking all elements. You are given an array nums consisting of positive integers. Starting with score equals to 0, apply the following algorithm. Choose the smallest integer of the array that is not marked. If there is a tie, choose the one with the smallest index. Add the value of the chosen integer to score. Mark the chosen element and its two adjacent elements if they exist. Repeat until all the array elements are marked. Return the score you get after applying the above algorithm. So what they are saying is that in the input, we are given an integer array nums and we need to apply an algorithm over this. So initially, all of these elements are unmarked. Now what we need to do is that in each operation, we need to select the smallest integer from nums. Right, and if there are multiple occurrences of that smallest integer, then we need to select the one which is having the smaller index, right? So now, right now in our nums array, the smallest element is 1, right? This one is unmarked at the moment. So what we will do is that we will mark this one and its adjacent elements and we will add 1 to our score. So initially, our score will be 0 and now since we picked 1 and it is not marked, we will add it in our score. So the score will become 1 now and now we will mark 1 and its adjacent elements. So these three elements will be marked, right? Now, what is the next smallest element? So that is 2, right? Now, in this 2 is having smaller index, so we will consider this first, but this one is already marked, right? So we will consider this 2. Since this 2 is not marked, it will be added in our score, so score will become 3 now, and this 2 and its adjacent element 5, both of these will be marked. Next is 3, it is already marked, right? Next is 4, 4 is not marked, so it will be added in our score. So score will become 7 now and 4 and its adjacent elements will be marked. Now in our array, all the elements are marked, right? Next element would be 5, that is already marked and we are done with all the elements. All of them are marked and finally our score is 7. This is what has to be returned as our answer, right? So this is what we are supposed to do. Right. So now how are we going to solve this? So one of the possible ways of solving this problem is that, see, firstly, you are selecting the smallest integer, then you are selecting the next smallest integer, then next smallest integer, and so on, right? So basically, if I sort these numbers, then my array will look like 1, 2, 2, 3, 4, 5, right? This is what my array will look like. And the order in which I will be selecting elements from num is this particular order only, right? So if I sort this nums array like this, then I don't have to identify again and again that which is the smallest integer in my nums, right? I can simply iterate in this array from left to right and I will be able to identify that which is the next smallest integer, right? But the only problem with this is that since we have sorted this array, we have lost the original indices of the elements. As you remember, we needed to mark the element that we are taking and we needed to mark its adjacent elements also, right? But since now we have lost this, then how should we mark the adjacent elements? So what we can do is that instead of just taking the elements, we can take a vector of vector or we can take a vector pair, right? And in each pair, we can store the element which is our number and its index, right? And then we can sort this. So it will sort on the basis of the element and corresponding to that we will have its original index, right? So if let us suppose I am taking a vector pair named sorted, right? Inside this I will push a pair in which the first element would be nums of I, whatever is the current index, and the next element would be the index itself, right? So in that particular case, this will look like first we will have 1 comma 1, then we will have 2 comma 0, then 2 comma 5, then 3 comma 2, then 4 comma 3, and then 5 comma 4. So this is how our sorted array would look like, right? Now what we can do is that we can maintain an array named marked, right? So this will tell us that which all elements are marked, right? So it will be similar to the size of nums, right? So we can create it as a Boolean vector, right? And initially we can keep all the values as false, right? Now what we can do is that we can start our iteration in this sorted array. We will take an element. right? So the first element is 1 comma 1. So first we will check that is this particular index 1 marked or not. So since it is not marked, so what we will do is first we will add this number in our score. So initially we will take a variable answer which will be 0, right? So since this index was not marked, we will add this number to the answer. So answer will become 1 and we will mark this particular index inside the mark, right? So this will become true now, and we need to mark its adjacent elements also, right? So firstly you will check whether does the adjacent elements of this index exist or not, right? So for 1 minus 1 is 0, 0th index exists, and 1 plus 1 is 2, second index also exists. So at index 0 and 2 we will mark them to true, right? So these will become true now. Then we will take the next element, right? So from next element the index is 0, it is already marked, right? So we won't be doing anything, we will move forward. Then we will take this 2. Now in this 2 the index is 5. So we'll see that okay, 5 is not marked. So first we will add it into our score. So the score would become 1 plus 2, that is 3, right? This is the number that we would be adding. Add an index 5 and its adjacent indices. One of the adjacent indices will be 5 minus 1, that is 4. 4 exists. And next would be 5 plus 1, 6. 6 does not exist. So we will only mark 4 and 5. So both of these will be marked, right? Next we will take 3 comma 2. So index 2, we will see it is already marked. So we will move forward. Then we'll come here. Index 3, it is not marked. So first we will add this number inside the score. So the score will become 3 plus 4, that is 7. And then we will mark 3. And then 3 minus 1, that is 2. And 3 plus 1, that is 4, right? So here 2, 4 are already marked. We will just mark 3, right? Then we'll take the next element 5. This one is already marked. Then we'll move forward and we have exhausted the sorted array, right? So with this, at the end, we will be able to identify our answer. We can just return this answer, right? So with this approach, we had created a vector pair out of this nums array, right? And that we are sorting. So sorting will take n log n time, right? And then we are also iterating n times inside this sorted array, right, to mark each of the element and add valid elements into the answer, right? So this will run n times, but this one is bigger. So the overall time complexity of this approach will be order of n log n. And if we talk about the space complexity, so see, first we are taking a marked boolean array which is of size n, and we are also taking a vector pair which is also of size n, right? And since we are sorting, so sorting itself inside it takes log n time, right? So we can say that our space complexity will be somewhere around n plus log n, something like this, right? So now let's look at the code of this approach. So first of all, let's create an answer variable which will be 0 initially. Then we'll create a vector pair which will store both the things as integer. We will name it sorted, right? Then we will run a for loop of I starting from 0, I less than nums dot size. And since we will be using nums of size again and again, let's create a variable n which will store nums dot size, right? And then here we can use n. And then we'll do I plus plus. Then inside this, in the sorted, we will push back nums of I, comma I, right? Then we will sort this. So sort sorted dot begin, comma sorted dot end, right? Then we will create a boolean vector for marking our numbers. We will name it marked. Its size will be equals to nums.size, and initially all the values will be false. Then we'll run another for loop of I starting from 0 till n, and we'll do I plus plus. Inside this, what will be the number? The number will be index I in sorted dot first, right? And the index will be index I in sorted dot second, right? Now if this number is not marked, if this index, right, with the index we will be able to identify whether this particular number is marked or not. So if it is not marked, then in that case first in the answer we will add this number, then we will mark this particular number, right, and then we will mark its adjacent elements. So if index minus 1 is greater than equals to 0, then in that case at the index minus 1 we will mark it to true. Then if index plus 1 is less than n, then in that case we will also mark the index plus 1 to true, right? And then at the end we can return our answer. So let's run this now. So our test cases are accepted. Let's submit this. So it got accepted. Now there is one more approach of solving this problem. Instead of creating this vector and then sorting it, there is one more approach that we can follow. Although time complexity and space complexity wise, both of them are almost the same, but still let's discuss that approach as well. So see, what we wanted was that what is the smallest integer at any point of time, right? And for that purpose, we had created another array and sorted it, right? Can we use some data structure which already gives us elements in the sorted order? Since we want the smallest element at each time, can we consider using a data structure which gives us the smallest element each time? You guessed it right. We can use a min heap over here. What min heap will do, it will always keep the smallest element at the top, right? And there also, since when we will push all of our elements inside the heap, we will lose their original indices. So we will have to store a pair, right? A pair of the number and its index, right? And then this marked array we will need again, right? So what we can do is that we can create a min heap, right? And inside that min heap, we want that if two elements are having the same value, then they should be sorted on the basis of their indices, right? So first we will push all the elements from the nums with a pair of their indices inside our heap as we did in sorted, right? But now we do not need to explicitly sort the heap because that will be already taken care of, right? And then we can just simply check that while our heap does not become empty, we will take the top element from the heap and then we'll check if it is marked or not, and again entire same process, right? So let's quickly look at that code as well. Now again we will take a answer variable which will be 0 initially, right? Then let's create a vector boolean named marked. It will be equals to nums.size. We'll take a variable n to store nums.size, right? So if this marked will be equals to nums.size, initially all the values will be false, right? Then we will create a min heap, and in C++, min heap is implemented using a priority queue, right? So we will create a priority queue and it will store a pair, right, of integer comma integer, right? And since by default it is created as a max heap, we will have to explicitly tell that it is a min heap. So we will write vector pair int comma int. Now here we want that if the numbers are equal, then they should be sorted on the basis of their indices, right? So for that, we will have to create a comparator, a custom comparator, right? So for that, what we'll do is we will use the declare type and we'll give it some name, let's suppose CMP, right? And then we'll close it. Let's name it PQ and we'll pass CMP here, right? So we will be defining this custom comparator, and inside this we will tell that okay, if the elements are equal, then sort them on the basis of the indices. That is, if the first element in the pair is equal, then sort them on the basis of the second element, right? So here what we will do is we will declare CMP, right? So this is the syntax for declaring the comparator. So each element in the heap is a pair of integer comma integer, right? So we will get two pairs each time. One is pair 1, other one will be pair 2, right? Then if pair 1 dot first is not equals to pair 2 dot first, that means the elements are different. In that case, we need to sort them on the basis of elements only, right? So we will return pair dot first greater than pair 2 dot first, right? Otherwise, we will return pair 1 dot second greater than pair 2 dot second, right? So basically, this particular condition will sort our elements in increasing order, right? And this particular condition will sort our elements on the basis of their indices in increasing order, right? So this is how we create a custom comparator. And this declare type, it will kind of deduce the type of this particular expression. This is a keyword in C++. Okay, so this is how we created our priority queue or min heap. Now let's push the elements from nums into the heap. So we will run a for loop of I and we'll do I++. Inside this in the heap, we will push the pair in which the first element will be nums of I and the second element will be I, right? Then while our PQ is not empty, what we will do? We will take the first element which will give us a pair, right? So it will be LE PQ dot top, right? And then we will pop it from the heap. right? So our number will be le dot first and the index will be le dot second, right? Then we can check that if this particular index is not marked, then in that case we will add the number inside the answer, right? Then we will mark this index to true, then we will mark its adjacent elements. So if index minus 1 is greater than equals to 0, in that case, we will mark the index minus 1 to true. And if index plus 1 is less than n, then in that case, we will mark the index plus 1 as well to true, right? And in the end, we will return our answer, right? So this is what our code looks like. I missed a semicolon here. So let's run this now. So our test cases are accepted. Now in this particular case, if you see that we have taken a Boolean vector, then we have taken a priority queue inside of which we are pushing our elements, right? Now here we are running this particular loop n times, right? And then we are pushing elements into our min heap or the priority queue, which takes log n time, right? So this particular for loop is taking n log n time. Then inside this, we are checking that while our heap does not becomes empty, and in our heap we had added all the elements of the nums, right? So the size of this priority queue will be n, and this while loop will be running n times, right? And then inside this pop operation is going to take log n time, and the other operations, those are constant only, right? So this particular loop will also be taking n log n time, right? So we can say that the overall time complexity of this code is also order of n log n. Looking at the space complexity, so again we have taken a marked vector which is equals to the size n, and then we have taken a priority queue which is having a pair, and this also is equals to the size that is n, right? So we can say that the space complexity is n plus n, which is 2n, and since 2 is constant, we can write it as n, right? So let's submit this. So it got accepted. Thank you so much for watching. Please like the video and subscribe our channel.